This is quite an interesting one. We've got two functions, an exponential and a straight line. So let's go for the exponential first. Exponential. And we have a linear function, and the linear function intersects the exponential function on the y-axis. So it's got to go through there. We have a point of intersection. Let's call that K. So let's just call f of x as a linear function, so it's mx plus c. So y equals e to the x will go through the point 1 there, where x is 0. Therefore, that c is also going to be 1. So that is the function we're trying to find. We've just found that there's the 1, so clearly we need to find m. Okay, the area in between these functions is equal to 1. So I don't know how far down we go. So the integral from 0 to k, it's the linear function on top. So it's mx plus 1 minus e to the x, and that will equal 1. Clearly we cannot put that into nsolve yet because we've got two variables. We don't know whether we're going to solve for m or k, ideally m, but let's just see how we go. Usually we would find this point of intersection by solving simultaneously, and we would get x equals. But you can see that I can't get x equals there. So that's something we haven't had before. Let's think another way around it. So I've set here that this point of intersection here is going to be k. So that point, this point here, actually lies on the exponential. So when x is k, y is e to the k, and that's a point on the exponential function. On the linear function, when x is k, then the linear function y value is going to be mk plus 1. These 2 points are actually the same point. Yeah, they're the point of intersection. Therefore, we can say e to the k is the same as mk plus 1. That is our second equation with an m and k's in them, and we're going to use that to get rid of that m and that k. So we've just got one equation to nsolve. So let's get from this thing here, m must equal e to the k minus 1 on k. So we're going to put that down there. So let's just get rid of that m and go e to the k minus 1 on k. And now we can just solve for k. We're going to nsolve that in our calculator. I've got my calculator here, I've already done this. So, and we get from there k equals 1.687. Because it's tech active, we're going to be as accurate as we can. Now, the question wanted, clearly I need to find m there, so finding k doesn't really do much for me. So what I'm going to do is I'm going to work out what this point is. That point is going to be the point k, 1.687, and then I'm going to do e to the k, and go that point of intersection is actually 5.40807, blah, 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 blah. That is this point of intersection here, and it also lies on the linear function, so it must satisfy the linear function. So I'm going to use this point here in y equals mx plus 1. So when x is 1.687, y is 5.408, etc., etc., as many decimal points as I can, and I'm going to get m equals 2.611. And that's our m for the function. So we get this y equals 2.611 585 x plus 1. So it does come together, but that's a new way of getting around the fact that we can't find a point of intersection between those given functions. It's a great question.